Welcome to episode 263 of CppCast, the first podcast for C++ developers by C++ developers. I'm our host, Rob Irving, joined by my co-host, Jason Turner. Jason, how you doing today?
I'm all right, Rob. How are you doing?
Doing good. I wanted to ask more about this announcement I saw on Twitter right after recording last week. Is that something you want to talk more about?
Well, my announcement that I'm working on a book was preempted. So it's out there for pre-release at the moment. I'm still working on it.
Okay.
But no, let's talk about it more after I actually officially finish the book. But listeners who are curious can go and find it. It's out there. And, yeah.
Well, can you at least say just how far along is it so far?
So I would say probably about 85-90% done with a book on
Okay.
C++ best practices.
Awesome.
And it's supposed to be just like simple, actionable items is my goal. So each section is intentionally very short and simple.
Okay. But so as you're saying, you hadn't planned on officially announcing it yet, but it kind of got out there a little bit last
Well,
week.
I hit the make this book available, and then because I had talked about it on Twitter that I was going to do it, and then I said let people register to be notified when it was available for pre-sale.
Okay.
And then I made it available for pre-sale, and then people started talking about that on Twitter, but I was still just going to try to keep it quiet for a little bit longer until the book was done.
I apologize then.
That's fine.
We'll talk more about it when it's finished then. Okay.
Right.
All right. Well, at the top of episode, I'd like to read a piece of feedback. This was from a few weeks ago when we had Slobodan on talking about his book, Modern C++ for Absolute Beginners. And this commenter on Reddit says, stop calling it modern. It's been modern for almost a decade now. I get that C++ is a slow-moving glacier, but the qualifier adds no useful information and just makes results more difficult to search for in the future. Idioms change in post C++ 26. I really don't want to continue searching for modern C++ only to find pre-C++ 20 material. I think it's probably been more than a decade. You know, the modern C++, that term came about way before C++ 11, right?
It did, but the way we all use it right now, I think, was because of Scott Myers's Modern C++ book.
Right.
Effective Modern C++, which was 2012 that it was actually released, I think. I have to double check that.
Right. So yeah, I'm not really sure if you're ever going to be able to get people to stop using that term. I don't know. What do you think, Jason?
We could call it Modern C++ 20.
That's true. That's true.
No, I don't know because there's a problem because you can be using C++ 20, but still be using C++ 98 techniques when there's better idioms and better options available. So how do you qualify that you're using the latest and greatest best practices and idioms that are available? I was just running through some of these things in my book about concepts and how much they can make the code better, but most people don't have access to concepts yet. So I don't know, how do we call that when it's time to say yes, modern C++ now includes concepts? I don't know.
Yeah, I don't know either. Okay, well, we'd love to hear your thoughts about the show. You can always reach out to us on Facebook, Twitter, or email us at feedback@cppcast.com. And don't forget to leave us a review on iTunes or subscribe on YouTube. Joining us today is Oleg Rabaev. Oleg is a C++ developer who cares deeply about proper software design, clean code and testing, experience in building large-scale financial trading and risk management systems, in-memory databases, and reusable libraries. Oleg, welcome to the show.
Thank you. How you doing, guys?
Good. I think we have to congratulate you on possibly the shortest bio that Rob has ever had to read.
All right, then.
I appreciate the to the point terseness here about the things that you really care about as a developer.
I like things simple and short. That this was not always the case, but as you evolve through your career, you learn to do things simple. Simplicity is good.
As the older you get, the more you ask the question of how little code can I write to solve this problem?
Absolutely. There you go.
I like it.
Okay. Well, Oleg, we got a couple news articles to discuss. Feel free to comment on any of these, and we'll start talking more about what you're up to, okay? Okay, so this first one is the 2020-08 ISO mailing is now available. It's a fairly short one, but I guess they're putting this out every month, so there's only so much that makes it per month.
Mhm.
Any highlights for you here, Jason?
Not particularly, but more questions than highlights from my perspective. These mailings are coming out regularly, right? And the committees are still meeting remotely.
Yeah.
But I don't think I've heard of a single paper that was accepted for C++23 yet. Have they been accepted? Is there some list of these things? How do we deal with the fact that they're not having the meetings where people vote on things and it officially moves forward?
I think, correct me if I'm wrong, but I thought we talked to someone who said that they're basically, voting on these things virtually, kind of giving a tentative thumbs up, thumbs down, with the plan being that, these things that we are virtually approving now, we wanted to actually vote in person on when we're able to.
Okay.
Does that sound right? Am I making that
maybe.
up?
It's possible you made it up, but it doesn't sound false. Oleg, do you remember? Do you know what's going on here?
No, but I like the fact that they have a proposal for stack trace and the transactional memory. That looks very interesting to me personally.
Okay, so yeah, based on your bio, it does sound like transactional memory would be interesting to you. Transactional memory is one of these things, like it was the hot new topic in like the early 90s, and then people stopped caring about it, and there's been proposals in and out of the C++ standard. What are your thoughts on transactional memory?
I mean, if you have a transactional memory, they really simplify the multi-threaded algorithms, right?
Okay.
Multi-threaded code is extremely difficult, right? Especially these days with modern processors, there are some very optimized algorithms like lock-free and wait-free, right? They're very difficult to write. And I think transactional memory would facilitate in that. So basically, the way I look at it is that you make a change to a bunch of memory, and then someone else's will only see the changes when you commit the transaction. Now, how syntactically and semantically it's going to look like in code, I haven't actually looked at the paper, right? But this is something that's very interesting. All your changes are treated as atomic, right? So just like atomic variables in C++ 11 and on. So this is something very interesting. I would definitely like to play with it once there is something stable or experimental.
Do you know, can we think of this like database transactions, like begin transaction, do some stuff, and then commit it?
Absolutely. Or for example, if you're writing a concurrent binary search tree, right? Concurrent red-black or AVL tree or concurrent hash table, it would be very helpful there, I think. There are some hash tables, for example, implemented using lock-free algorithms, right? And those are very extremely difficult to debug and design. It's like a black magic on steroids, like quite literally. So I think it would really be helpful in that sense. And stack trace, C#, I think Java, they always had it. It would be nice to have something like that in C++. Not from the core down, but actually be able to, something that allows you to look at your stack much easier than it is now.
Yeah, it looks like that proposal is based on the Boost backtrace
library, right? I haven't looked. I just scanned the headings, and I like those too.
I feel like this is one of these things where, and I'm probably exaggerating here, that it's going to face problems because, like the standard doesn't acknowledge that there actually is a stack or something like that, right? Like, because this is the kind of thing that tends to happen.
Yeah.
But it's already on its... Wait, where did it go? I just clicked on it.
It is in LWG, so it made it past LWG evolution. Is that what you were going to say?
Yeah, and it's on its 6.3 vision. So it's definitely moving forward. So I guess I should be more optimistic than that.
Right. Okay, next thing we have is an article from the Visual C++ blog, and this is introducing vcperf/time trace for C++ build time analysis. And we had Kevin Cadeau and Cy on a while ago talking about this feature. And this is actually a guest post from a game developer from Mercury Steam Entertainment. I don't think I'm familiar with that game development company, but he used the C++ Build Insights SDK that we talked about with Kevin and actually wound up submitting a new feature to it, and it's to output this graph that you can actually view in Chrome, which is pretty cool.
Yeah, that's effectively exactly how Klang's time trace also works.
Okay. And I thought it was interesting how they found some, issues in their own code using this. One of the things they mentioned is a particular default constructor, which was defined by the compiler, that was taking 3% of their total build time. So they just went and, put in that constructor themselves and saved 3% on their build. It's amazing.
Wow.
Yeah.
But sadly, it's only available for Visual Studio, right?
Yes, this is for Visual Studio. Yeah.
The good old days.
Well, Clang does have similar functionality as well. I forget what its parameter is called now. /analyze, perhaps. But yeah, something else for our listeners to look into if they're interested.
Yeah. Okay, and then Jason, did you want to share this last one? This is a post on the CPP subreddit about optional virtual destructors.
I thought this was interesting, because the poster here asked, how come GCC and Clang are giving, one of them is allowing this code to compile and the other one is not. And it was using a technique that I recently had on C++ Weekly for having multiple destructors in your class with C++20's concepts, because you can constrain your destructors. So the destructor only exists if it matches the constraints. And this person wanted it to be virtual or not virtual. And I just thought it was fun. This is just because it's so easy to ask these questions today, if you manage to formulate your question in a way that people can read and provide a Godbolt link to it and whatever. And the top answer on Reddit is a quote from the standard: "A virtual function shall not have a trailing requires clause." It's just right there. But they got the perfect answer just by asking the right question. It's well formed and it was timely with C++20. So I liked the article. Not even an article. It's a 3-minute read. That's all.
Okay, so Oleg, so you actually reached out to us, asking about coming on the show after we recently talked about one of those JetBrains State of the Community posts.
Yep.
In there, they talked about what unit tests are C++ developer using, unit test libraries. And over a third of respondents to that poll said they don't write unit tests for C++. So what are your thoughts on that?
Complete and utter shock.
Did you cry after this?
No. I think if George Costanza was a C++ programmer, he would say the worlds are colliding at this point. I was completely shocked. Yeah, this is 2020. I can understand 10 years ago, right? I think the unit testing itself picked up at the beginning of Agile movement.
Mm-hmm.
I wrote my first unit test probably in 2008 without even realizing that I'm writing a unit test, because I just wanted to write a small program that sort of tests a small piece of code. And I had main function where I would have a switch statements, comment it out, but I had no idea it was a unit test, but actually it was a unit test. And then I was introduced to the Google test framework, right? And for me personally, it was a paradigm shift. And since then, since about 2010, I've been hooked. So unit tests in general improve the quality of your code. I think someone mentioned if you write a clean code, you don't have to write unit tests, right? In one of the comments you mentioned on the show.
Uh-huh.
And I'm like, how can you write a clean code without unit test? So I'll tell you the real story, right?
Okay, go ahead.
So I was working on a project. It's actually in-memory database, right? So I'll describe it in very generic terms. basically, it's multi-threaded. It has a SQL compiler, basic data type. Composite indices has alter table operations on running database. Replication, the cluster should never hold down. It should be like 24/7 operational, stuff like that. Processes tens of thousands of messages a second. Has a lot of log3 data structures. So it's extremely complex system, right? So we hired a developer into the team who was supposed to help out, sort of support it and extend the functionality. And in case, just something happens to me personally, let's say, right? Someone can take over. Sure. Like Jeff Bezos decides to adopt me, right? So
is that your retirement plan?
No. Okay. I'll never retire. I'll always say it to my my family. I will die coding, right? So he joins the team, and I expect the questions, right? Like it's naturally very friendly. He doesn't ask me a question on day one. He doesn't ask me a question day 2, 3. The week goes by. 2 weeks ago, I am starting to think the guy doesn't like me. Then I turn to him. It's like, why don't you ask me a single question? It's a pretty complex system. He says, Oleg, I don't need to. Every time I want to find out how a particular component works, I just look at the test, and it's there. I don't need to ask you a single question. That particular system had several thousand units, interaction, and integration tests. So that's this is my philosophy personally, and I try to, preach it. I was not always like that. I wrote a lot of spaghetti code at the beginning of my career, just like everyone else, let's be honest. I assume I sometimes do the same thing, right? And it's not up to me to judge, but I always try to improve my design skills. And I feel that there has to be some kind of methodology that allows you to achieve that easily. For example, we all agree it's much easier to program in C++ than in assembler, right? That's
usually, yes.
Usually, yeah. Right. I'm not sure about C++ 26, right? But so, like, for example, we have a static typing in C++, right? If you have an integer and you're trying to assign string, std string to an integer variable, the compiler will not let you do it, right? You can't just move memory, like it will prevent you from doing that. Things like that. So it's built into the language where the compiler sort of is guiding you and not allowing you to do certain things, which would be stupid, right? Now, with testing, I treat testing as my guide to a design. Whenever I work on any piece of code, I always think, how am I going to test it? And I don't always think about a particular library or service. I always look at the system as a whole. How am I going to test it? Mm-hmm. So there are 3 simple rules that I try to follow. Number 1, write always small functions, right? There are a lot of fancy jargon out there. What if you want to, let's say, promote some sort of like developer philosophy, you want to make it as simple as possible, right? Just like the bio. So guys, we should all write small functions. The code should be modular. And I think several guests, I remember just recently, several months ago, was a guest who was actually pretty funny, and he mentioned about small functions. This is just basic stuff, right? The next thing would be no cycles. So when I joined Bloomberg, you all know, I'm sure the C++ community know John Lakers, right?
Right. Mm-hmm. And he's been on the show, yeah.
Yes. And I was introduced to his, he has a lot of YouTube videos, right? And I watched his stuff, and some of his ideas are revolutionary, right? So, but one thing that I take away for myself is the hierarchical design and no cycles under any circumstances. With some exceptions, I'll elaborate on that. What does it mean? Like if you have component A and component B depends on component A, they should not be cyclical dependencies.
Oh, okay.
Or if you have anything like component C depends on component B. Component A should never depend on component C, right? Because B depends on A. You should not have cyclical dependencies in functions, in classes, in libraries, in services. You should not be, in my opinion, there should not be cycles. And I had code prior to that with cycles and once I started following that philosophy, it actually improved the design and testability of the code. So actually, John mentioned they asked him, I think one of the talks, it could be on your show or maybe it's from some of the YouTube videos. What do you think the biggest benefit of modules? So I think John Laika said, for me, it's almost impossible to create a cyclic dependency with modules, right?
Yeah, that might have been his interview on here. Yeah, that does sound familiar.
Could be, yeah. So no cyclical dependencies. So, and it's very easy to achieve. Just follow those rules, right? So small functions. When you say small functions, then everything becomes small. You have small classes, smaller libraries, smaller services. You just break your components into smaller pieces and make them reusable. No cycles. And number 3, tests. These are the 3 rules that I personally follow. Make your code testable and design for testing, right? So if you do that, and even if you don't read any other books with 1,000 definitions, right, which a person can get very discouraged from by just looking at stuff and say, like, there is this kind of test, there is approval tests, right, regression unit tests, there is behavior-driven development, there is this, and like, where do I start? Like, well, I have to know all this in order to be productive. So I think you should always start with the simple principles, and there is like 80-20 rules. By following these principles, you will cover 80% of your design, in my humble opinion. So I just gave you an example. Your tests become your documentation. They express, you express your code through the test. In fact, if it was up to me, let's say if I wrote, you guys use Compiler Explorer or the Wandbox, right? I like Wandbox, right? Whatever it is. But there is always a main function there, right? To me, it shouldn't be a main function. There should be text fixture. And instead of doing the cout and looking at doing that, I would rather use the assert macros or require macros, right? This is my philosophy. This is like, if I started on something new, I want to test something, like I don't write a main function. I will have a test fixture, and that's where I will basically play with my code or stuff like that, right? Using the assert macros or expect or require, depending on the framework you use, instead of doing the couts and stuff like that.
Okay, so you mentioned like a ton of terms just now.
Yes.
So it kind of sounds like you do what most people would call test-driven development. Is that fair, or?
Yes, but not religiously. I will explain what. I don't write my test before I write my code.
Okay.
Yeah.
Okay.
But
so that is typically what test-driven development would be, right?
Well, there is it's one of those arguments. There are a couple of camps. It's like, what's better, VI or Emacs, right?
Right.
And some people do it this way, some don't. I don't personally, because it hinders my design. I mean, it's just more difficult for me like that, because then you start losing. I don't want to criticize that, so I don't want to but basically I don't do it. But I will write a test for every public function of my class. Okay, we're C++ program. Let's talk about public functions, right? That's the only thing you can really test. I will write a test, at least one test, for every public function.
Okay.
Probably there will be more tests, because you want to test function in, fulfill the contract of the function, right? And then test the exceptions and the corner cases, stuff like that. I don't test undefined behavior. That I will not test.
Okay.
So
that sounds like, when you see that people do things like pound define private public to be able to make their class testable.
No. It's a no for me. I discourage that personally. Well, if you do stuff like that, then maybe your class is too monolithic and you should break it up into smaller classes, right? If you have too many private functions that are in itself provide some testable functionality, maybe you should make them part of another component and use that component as a composition inside of the class, right, as a client.
Right.
Yeah. But I would never do this. I don't like to pollute my code with things like that. No.
Yeah, so for the sake of our listeners, that is possible technically with most compilers, that you can do that, and then all of the private functions in a class become public. And yeah, but it's not It's not a good idea usually.
I don't advise it. Yeah, I tried it once, like
Yeah.
a while back, but no.
So, and you said you don't want to get too caught up in terminology, but but I do kind of want to dig in a little bit. It does sound like
Sure.
what you do advocate specifically for what most people would call unit testing, individual functional testing.
I advocate way more. So if you want, I will elaborate on the different type
Sure.
of tests that I personally write. Okay.
Yeah, sure.
So I think everything is a unit or integration test. Everything else is just the derivative of it, right? If you really
Okay.
think about it, and I'll explain what the unit test is in my humble opinion and the integration test. And there is another thing that maybe it's a concept that I heard in one of the some lecture, I believe, even somewhere on YouTube. And I like that concept, so I'll talk about its interaction test. So what is the unit test, right?
Test.
Yeah.
I've never
What is
heard
the
that
unit
term
test?
before.
So now is the chance. What is the unit test, right?
All right.
So the unit test is basically, it's just a small program with minimal setup code, right? A small program with minimal setup code which exercises some narrow part of your public function of a class.
Okay.
That's it.
Mm-hmm.
Now, what is the interaction test? Interaction test is a unit test with more complex setup. Now, what does that mean? As you build your component, let's say, for example, if you're testing vector or a string class, right? You will only write unit tests because vector in itself is more like a vocabulary. It's just it doesn't interact with any other components. But as you build your class hierarchy, right? The testing becomes a little bit more complex, correct? Because you have to do more things just to set up the code in order to test your higher level components. So those kind of tests I call interaction tests. And then there are integration tests. Integration tests is either unit test or interaction test with external dependency. That's all it is. Meaning, if let's say you write database successor, right, and you have function select by primary key, you have an external dependency on the database, right? Let's say it's a SQL Server database. So in order to test your code, you have to have an instance of the database running.
Okay.
So you have the dependency, and that makes it a little bit harder to test, right? Integration testing is more harder because what if it's a more complex dependency, like you use some kind of message queue mechanism which requires the setup, or you talk to your service over TCP/IP connections, right? That's the integration test. Now, the community tends to merge the interaction test integration into one concept. I split it just so to make interaction test just like integration test, but without the dependencies. And my rule is I always try to achieve unit and interaction tests and remove external dependencies. And there are ways of doing that. But you have to design your system to start with to do that. And I can elaborate on that. For example, in the story that I told you at the beginning about this large scale, in-memory database, one of the things I was able to test without any kind of dependency is communication protocol, replication. If one node goes up, another one goes down, things starting, exchanging information and everything continues working. How do I do that without having any kind of external dependencies on file or on TCP/IP or anything like that? So
Great
the way
question,
you do it,
yeah.
yes, the way you do it is the following way. There is a technique called, it's a widely used technique in Java, I think, like dependency injection, right? So what you have, let's say you have a component A that talks to component B using component C. And component C is a TCP/IP interface, right? Let's say we're writing a ping server, a ping client. So the ping client code just says, I'm sending something using B to C, right? C is the server, A is the client, B is the middleware. So how do you test that? Okay, you have to start your server, right? That will listen and bind in the socket, and then the client will open the socket connection, etc. Do you do it like that? No. What you do is, since you are communicating between the client and the server using the middleware, implement that middleware as an abstract interface, which has a function send, for example, right?
Mm-hmm.
And that abstract interface can be plugged into the file, injected into the client code and provide in-memory implementation. Instead of sending data over physical network, send the data over memory, just dump it into the vector of bytes, right? And do the same thing for the server side. So during your setup code, you basically replace that interface, the actual network layer, with your own implementation, right? Which is in-memory implementation. And you can test your system end-to-end without external dependencies. So I'll give you another example. For example, let's say there is a MySQL or SQL Server database, right? You cannot test it unless you start up the service, right?
Right.
But you could do this with SQLite, correct? I think SQLite is something that you can bring up in the process, right? You don't need the actual service instance running, right? So if the SQL Server developers or MySQL developers thought ahead a little bit and thought, like, how are we going to make our system much easier to test, that would provide ability to start some kind of light database engine on the client without any kind of external dependencies, that works completely in memory, right, with a simple interface, and you can test your code this way. In fact, recently I looked into one of the graph databases. I think it's Neo4j, and they actually did that. They say, okay, guys, if you want to unit test, you don't have to run the database engine. There is an in-memory implementation. So when I write my code, whenever I have a chance, you don't always have this chance, because sometimes you depend on other systems, right, or on other open source projects, which simply don't. But if you're working on the infrastructure component, you should always design it for clients so they can test it easily without external dependencies. It will make you will start thinking differently, right? You'll say, oh, you know what? I have, let's say, optimization engine, which I want to separate so that I could run my stuff in a lighter mode. Oh, it actually leads to much better design. So this is, you do want to turn your integration tests into unit tests. That's the goal. It's not always possible, but that's what you want to do.
So you talked about, these three types of testing that you focus on. Do you assign kind of weight or importance differently on them? Like, how many unit tests do you have compared to the number of integration or interaction testing?
That's actually a great question. Unit tests are usually applicable to lower level components, right?
Mm-hmm.
And you do want to test them in and out, like you want to do it to extreme. You want to have complete coverage. Now, as you go high level, it becomes almost impossible, because the amount of interactions, right, the amount of ways you have so many components in the pipeline, right? The amount of it becomes extremely difficult, right? So your number of tests will go down, but you do want to have tests that will will sanitize your code, sort of speak, right? Yeah, I mean, in this case, like approval testing, right? You can generate a bunch of, let's say, files, the input files, which becomes your golden copy, right? And then whenever you change your code, right, make sure there are no bugs. You can run through the same regression, right? And hopefully nothing is broken. Everything will get passed, right? But it becomes very difficult. It becomes very difficult to test as you go higher level. So more tests on the unit side. There will naturally be less tests on interaction integration side, but they have to be. So I think 80-20 rule works here. So there will be 80% of tests will be on the unit side and 20% on integration side.
Okay. So I'm thinking of a couple of different things here. Like, I've known some people that say that they don't really do unit tests. They only do behavior tests because they want to be able to swap out the implementation as long as they still get the same behavior from the system. Now, I was not thinking about that when I was working on my scripting engine, ChaiScript, years ago, which, just for the record, I haven't maintained in a long time now. But coincidentally, we have almost no test in there that tests the actual C++, like test like I parsed this and I expect this AST back. Instead, we just wrote things that only test the scripting engine. Like if I put 5 in, do I get an integer 5 back out? If I do 5 plus 4, do I get 9 back out of the system? Which gave us very good code coverage ultimately and let us know if any of the behavior broke in the system. But I'm curious about your opinion. Like, would you say that I did a bad job testing the system?
I think you did more interaction tests than unit tests.
Right.
You do want to test every component. And I think the behavior-driven testing applicable to unit test or interaction test is just, it's sort of like synthetic sugar, right? Depending on the framework we use, with like if, when, giving certain right input, when you do like, I think Catch has the supports it, right?
Yeah.
G-tests do not. But I think what you did more interaction tests, and I see it all over the place. You did a good job because you do have coverage, but I don't think you have enough unit tests because you do want to test your parser. You do want to test your lexer, right? You do want to test every low-level component.
Right.
For example, if you write a string class, are you going to test your string class from your client code by using it, or are you going to write unit tests for the string class? You should probably write the unit test for the string class, right?
That's a good point, yeah.
Yeah, yes. So I think you have more interaction tests. I don't think you have any external dependencies there, right? Because it's a scripting language. Right?
Yeah,
So,
no, it's, yeah.
So, but possibly you don't have enough unit tests. Yeah. And I think one of the most important tests are the unit tests, because once you test your low-level components, if you have a good coverage, you just like rely on them working. You never test your low-level components in terms of high-level components. You just rely on them working. That's it. And obviously you need the test end-to-end test, like you provide an input 5 and it returns to something else, right? Yeah.
Right.
Those are also replaceable. Sometimes people will go wild with unit tests and they will shine the integration tests. There is another extreme like that. They will mock everything, right? Like I think mocking is useful to some extent to break the dependency, right? Mm-hmm. If you don't control the infrastructure, let's say, and you're talking to a particular service, by giving some, I don't know, JSON input, you get some JSON output, right? So you don't want to start up that service and the whole infrastructure, so you mock it out. You usually what you do, you have a class abstract interface with some methods, like gets, requests some data and it returns you some kind of a response. So you mock it. In real implementation, it will go into that service and will execute code there, right? But in your mocked implementation, you're just going to basically, whenever you call get some data, you will return hard-coded or whatever other means you do that. So that you break the dependency and you can turn your sort of, you could unit test your components that interact with other components over external dependency, right? But some people take it to the extreme. They will mock everything, right? And I don't think it's useful because you could do that, but you will have to write tremendous amount of what I think could be unnecessary tests, because at the end of the day, you do want to do integration testing, right? And integration tests usually will catch a lot of errors that one missed during the mocking. Because at the end of the test that you want to test the whole system. Going back to my database example, right? I had only one, I did not really have I did have mocking there, but it was very limited. The way I achieved that, you could also say it's mocking, is I replaced all the communication with the abstract interface so that I can test everything in memory, right? But I would not mock every component interaction between any other component. No, I would just use the other components as they are, because they execute, like if you have a string and a vector and you build some, let's say, I don't know, some other class which includes the string and the vector, you don't mock that class. And there is another class which includes that class. No, you just use those classes like you did with your scripting, right? At the end of the day, you don't mock. you have your parser, you have your lexer, right? You have something else going there, and you have a client interface. You provide an input, you get an output. I'm a fan of that. You should really test each component with unit tests, fine. But at least you have proper interaction tests, right? So in fact, once I gave the presentation and, I decided to make a little controversial and I was trying to prove the point that to have, when you have external dependency and if you control the infrastructure, it's much better to, instead of mocking, just provide this in-memory implementation and a lot of times just test the system as a whole. So my second slide would say like mocking is evil, right? Which is obviously that was not the case. I was just trying to show that, just wake up people, right? Now they're paying attention, right? So I think you should know when to mock and when not to mock. But sometimes you have to do it. Especially mocking is good when you do test error conditions. For example, if you are testing your database, even if you have your in-memory implementation, right? How do you generate connection errors, right? How do you generate that something bad happened? It's difficult, right? Because it's difficult. So then you mock. That's a perfect case for mocking. Yeah. Another thing I wanted to mention.
I would like to say I really like that point, that mocking is particularly useful for the error case. I find that very interesting.
Yes. I use, for error case, it's the perfect case for mocking, right?
Right. Only way to consistently guarantee you're going to get an error.
Yeah.
Exactly. But I would be against mocking every component in the system. That would just be insanity. And I've seen people do that. Now, given what we just discussed, right? I think you could see that by following these practices, right? Just write modular code, don't create cycles, and test your code. It will not let you make bad design decisions. It's like you become your own compiler, so to speak, right? If you just discipline enough that you follow this very easy, writing small functions is very easy principle to follow. Mm-hmm. And there are beyond, there are books, there is a single responsibility principles. You have to have the smallest amount of parameters, this, that, and when you try to explain something to someone, you want to make it simple. The more simple you make, the easier it will be accepted. So I think writing small functions is a very easy concept. Creating no cycles is also easy concept. So are tests. Now I have my other three sort of statements which I want to run by you, which also guide my software design. If a component is hard to test, it's not properly designed.
Okay.
Number one. If a component is easy to test, it is a good indication that it's proper. It doesn't mean you could still have mess inside the code implementation, but it's a good indication that it's properly designed. Now, if a component is properly designed, it's easy to test. So whenever I write a class, I'm asking myself these three questions. In general, I'm asking is it easy to test? Right? If it's easy to test, it's a good indication that it's properly designed. And that's what design for testing means for me.
Now, I appreciate those guidelines sound good, but how do you... It sounds like a lot of what you're talking about, you're like, well, unit test a lot, but not too much, mock some, but not all the things. How do we start to develop this mindset, this intuition for what is good testable code?
What is good testable code?
How do we, we have to practice, it sounds
right. The only way, it's a paradigm change. For me, it was I find it difficult sometimes to bring it over, right? The finish line. Right. But once you get it, you cannot do things otherwise. So unit tests a lot. There is no end to unit test that you can write. Now, integration test, reasonable amount, but you are limited because they are literally, you have factorial explosion there, right? Because there are so many ways you can use the components. Mocking only when you need to test for errors conditions, or if there is a complex dependency, not external dependency, but even like within your project, sometimes you would do mocking just to separate another part of the system so you can test it easy, right? But I wouldn't mock everything, absolutely not. And integration tests, try to turn them into unit tests and interaction tests by removing external dependencies. And the way to do it is use dependency injection. Replace your communication protocols or protocols that talk to file systems or message queues, databases within memory implementations. It is sort of like mocking, except that the actual code is executed. It's just whatever would be executed on the server side is actually executed in your own process, basically, right?
Right.
So you want to turn all your tests into in-process tests. Now, the way people achieve this day, I mean, they don't really achieve that, but they use Docker for the integration test. So they have the environment, because the setup is very difficult, right? So they have the environment, they make sure all the dependencies are properly set up, they start up the container, right? And they run the integration test like that, which is great, but it's not pure in the sense that you cannot, I tend to write my infrastructure code so that I can test it in process.
Yeah, it almost sounds like you would think of that as cheating.
I didn't want to say that, but yeah, but it's a good cheating, right? I would rather do that than not do integration tests, because to set up the proper environment is difficult, right? Especially if you, it could be difficult, let's say it this way, right? It is, I don't want to call it cheating. I think it's a good approach. I've had good compromise.
Well, I've had a couple of students say, oh, well, I've got this class and I want to test it. I need to mock it. So I made all the member functions virtual so that I can, derive from it and, do the mocking kind of interface with it. And I respond to them and I say, I am not an expert in testing methodologies, but that doesn't feel right to me if that's the only reason you have virtual functions there.
Absolutely right, Jason. This is when I call mocks are evil. Quote unquote. Yes. Okay. I would not do that. No, I would do that when my class, let's say, returns an error condition which is difficult to replicate by providing input. For example, if you are passing to database engine valid SQL statement, you're probably not going to get connection error, right? How do you simulate connection error? So in that sense, if you have like some client for the database and you want to simulate connection error and see how your actual code will respond to it, mocking is great. Mocking is also good when you have external dependency, you don't control it, and you don't want to bring the whole environment up, right? So you break your external dependency mocking. Okay, acceptable. And also, even if you don't have external dependencies, but when you have complex interactions, like really complex, which requires very complex setup and between like two subsystems, so you can mock another subsystem, right? Just okay, that's acceptable, but not every class, no.
Okay. The other thing that kind of, concerns me, for lack of a better word, when I think about mocking and dependency injecting is I go, well, it feels like now I'm testing something different. Like I'm not testing the actual system, I'm testing the mocked system.
Yes.
But your arguments for being able to consistently generate errors, and it all makes sense to me, but I'm just curious, has that ever been a problem? Have you ever gotten down the road and then go, oh no, my mock actually gave me a false sense of security somehow?
Well, for errors, no.
Okay.
And for dependency injection, I just wanted maybe slightly correctly, I'm not sure if I understood you correctly. When you use dependency injection, the way I described it, by replacing the actual protocols, let's say TCP IP within memory implementation, you are actually testing your whole system. That's the whole point, because you are executing the code on the other side, which would be executed on the server side. Like you are doing end-to-end. That's the whole point of it.
You've just removed the operating system and the internet out of it.
You just remove the TCP communication. And now, should you test with the actual TCP IP component, right? Instead of doing dependency injection, should you actually test with the interface which implements? Of course. Okay. That's going to be the real integration test. They are irreplaceable. but they are a little slower to run, right? You have to have an environment, right? So you try to make your testing easier, designed for testing. It will drive your design, and it's going to create extremely stable system.
Okay.
I mean, look, I worked in a lot of different projects, right? I speak mostly from pragmatic experience than from like academia experience. So when you do things over and over again, right, and your code work in production, and it's easy to maintain, and I just told you the real story, right? I will not mention the company, right, but like where it happened, but I told you the real story. You think like you must be doing something right, and then why not to share it with the world?
Sure.
So my point is that in my previous experience, yes, I did not write unit tests. I think, Jason, I want to ask you, when was the first time you wrote the unit test? I'm actually interested. Like, when was the actual first time you wrote your first unit test?
Well, so I will say TriScript, that project was the first one that I worked on that actually had test.
Yeah.
So I will say, in my defense, but also
no, not I'm not putting you on the spot.
no, but also to condemn myself in a sense, I didn't even write the first test. My cousin who was working on the project with me is the one who wrote the first test. He's like, we need to have tests. I'm like, that sounds like a good idea. So go ahead and do that testing thing, right? Like I wasn't used to this at all.
Yes, true.
Yeah.
I heard like, I think it was like a panel between Strostrup, Pike, Alessandrescu, and someone mentioned like the unit tests were created for untyped, like interpreted type of languages, because like C++ gives you static time, but that's true maybe, but I think unit tests are useful across the whole industry. And in fact, I think they do drive your design. Like whatever you do, think, is it easy to test on? If it's not easy to test, red flag, your component is not properly designed.
Yeah,
and that's simple. That's simple, right? Like you don't have to read like 2,000 pages to understand that. You write a class. Is it hard to test? Yes. Wrong design. Easy to test? Yes. Probably you did a good job.
Do you mind if I quote you in the testing section on my C++ book?
Of course. I will send you those principles, the 3 things. Absolutely.
Okay. Go ahead, Jason.
Oh, I was just going to say it's funny because through the whole course of this, I've got in the back of my mind some code that I wrote yesterday that I'm like, this code is being used everywhere. So I know that it's tested and it is a strongly typed interface, but I should probably go ahead and write a unit test for it. I wasn't thinking about it for that particular function. So yeah, I'm going to do that when we get off the call.
The rule is like that. Every public function or every free function, that's easy, right? Every public function at least should have a test, probably with the same name, at least one, maybe more, depending on the corner cases and the complexities, right?
I feel like I'm seeing, kind of like a complete picture that from what I'm hearing from you, because like you said at the beginning that people get caught up in these different terminologies, and it sounds to me like you're in a way saying test at every level as much as you can.
Exactly. But be pragmatic, but never be a perfectionist because you'll never get anything done, right?
Yeah.
By the way, as far as, I will give you a good example. In my code, probably 60% of my code are tests.
60%
of the code.
Wow.
Okay.
Yes. Most of the code that I write are tests.
Is that like 100% code coverage then?
Well, I hope so, but sometimes when you use those tools that give you the coverage reports, right? It's just because you have a coverage doesn't mean you test every code path within your function, right? But yes, it is close to that. Yes. Okay. You will never be perfect. It's impossible to. If you're a perfectionist, you will never deliver all the time. You'll never get. But you have to be pragmatic and you have to be disciplined, right? That's the point. So if you want to look at how much testing code you should be, like it probably should be 50% of your code should be tests. That's my guide. Someone will say it should be even more. I will not argue, probably agree, but I'm at about 50 to 60%.
So looping back around to where we started with that poll about 34% of developers not using unit tests. If you're one of those in the listeners and they've been convinced they need to do some unit testing, you have any things to point them to learn a little bit more to get started? Any resources you might suggest?
Any resources? There are plenty of books. but I think the best resources would be maybe find an open source projects and just good quality open source projects and take a look at how they are tested. Also, YouTube videos, right? Bunch of YouTube videos. There is just plenty of stuff. For me, it was the real life experience, right? There is one particular book that I would recommend. It's called Clean Code by Uncle Bob, I think.
That one's been around for a long time.
Right. But interestingly enough, when I read it, I did not read the section about the unit tests. So I read it a long time ago, and then I'm like, I read it, didn't talk about tests. When I look back at it, oh wow. So he's advocating writing your test before writing code, which is fine. If you could do that, do that. But the main thing is test your code. Make your test to drive your design. If you have difficulty thinking how you can design, by the way, software design is extremely, extremely difficult, right? To achieve good quality code, small functions, simple. No cycles, and test. If you do that, 80% you're there. The rest are details.
I just want to, if you don't mind, mention again that you gave some techniques for testing error cases, because in my experience now as a more mature developer compared to the older projects that I started on, it seems to me that the error handling routines are never tested. Like when I look at code coverage reports on some of the projects I'm involved in, and I even submitted a test at one point on one project that had an error in it intentionally because I needed to test the error handling routine, and that pull request was denied. We don't want code with errors in it in our unit test framework. And I'm like, but we need to test that.
Yeah, you need to test that, absolutely. Whether you return the error or you throw an exception, the piece of code that like every code path should be executing during your unit tests. That's advisable. So, and if it's difficult to generate the errors, right, that's when the mocking comes handy, right?
Right.
Sometimes you can generate errors simply from the input. You provide invalid input. Let's say it's not undefined behavior, but there is a valid error code or exception thrown. By the way, I'm a big fan of exceptions. I hate error codes.
I have no problem with exceptions.
Yes. Remember, I remember in 2016, Eric Nibbler, right, who spoke about ranges at the time, and they're like, but you have to use exceptions. And he said, like, but the amount of time, did you actually profile it? The amount of time you have your if statement, which could potentially throw your compiler off or the CPU executor off, right? Probably, if you do exceptions, it's not going to cause any kind of performance problems. You should probably measure your code before you decide whether you use exceptions or error codes.
Yeah.
So.
Okay.
Yep.
Well, Oleg, it's been great having you on the show today. Where can listeners find you online?
Well, I'm not really social as far as Facebook and Twitter. I have a LinkedIn profile, and my email, you could post it into the notes. I have no problem people reaching out directly. And, I feel very passionate about what I do. If you find, let's say, flaws in my philosophy, please reach out. Prove it to me. Show me how it could be done better, right? This is my pushback. Like, show me. Sure. But I do have multiple successful projects behind me that are stable, that are working, that are in production, that are maintainable. So, and Jason, if you want to mention some of the stuff, I can write you an email in those principles, just like if component is hard to test, it's not properly designed. And
I think that's specifically what I want to quote, actually, that right there. So
I will do that.
All right, awesome. Thank you.
Okay.
Thanks,
Oleg.
Thank you.